Welcome to Neural Information Retrieval Talks. This is episode 5. My name is Sergi Castella. I work at Zeta Alpha. And today is a very special day because it's our first episode with an external guest besides our co-host, usual co-host.
I'm Andrew Yates. I'm an assistant professor at the University of Amsterdam.
And with us we have Antonios Krasakis.
Yeah, exactly. I'm a PhD student at the University of Amsterdam also. I'm working on Conversational Search, so it's good to be here.
Yeah, so the reason, like Anthony said, that we brought him on here is that we wanted to talk about conversational search. And he has, he's working on this actively, so he has a lot of this detailed knowledge that we might have missed otherwise. So I think that to begin with, I would like to explain why we think conversational AI or conversational search is interesting and disambiguate what those terms mean. So can you describe a little bit what are we talking about when we're talking about conversational search?
Right. So I would say it's a bit of a new domain. So people might call conversational search all type of different things, but what we're looking here in this paper is basically conversational passage retrieval, where the idea is that you have a system interacting with an assistant, like for instance Siri or Google Assistant, and so on and so forth, and he's trying to extract to satisfy some information needs that he has. So it's a search scenario, but this search is happening through a conversation rather than just going to a search engine and typing a query. And this is something that has been becoming more and more popular since we have assistants in our phones and also in our houses and so on.
So is this like a subset of conversational AI, or are they different some way?
So the conversation, the passage retrieval part is more rather than trying to answer specifically questions, we're trying to find documents from the web or Wikipedia or something like that that are close to what the user is trying to answer.
Mm-hmm. So something, I mean, it is taking a bit of a step back, but something I find really interesting about this whole topic of conversational AI, not only conversational search, is that when I ask my friends who don't know anything about computer science and stuff, and I tell them I'm working in AI, one of the first things that they bring up is these, computers that answer questions to you or kind of keep up with a conversation with you. And I feel that's kind of still historically probably a quite fundamental quest in the bigger picture in AI to solve, to make computers be able to carry on a conversation a bit like humans do, which is a bit of a hard task, I would say.
Yeah, it's a hard problem. And I think some of these neural methods are why we start to make progress, because now it's at least possible to somewhat understand what someone said and feed it to some other system, right? So we'll look at a conversational system that the query is fed to, but just having, neural methods that can understand the audio well enough to form it into a query, I think it's essential.
That's actually a very interesting point. When we, the audio point, are we talking about, does conversational imply that we're working with audio or with text, or is it both, or what are we?
So I think in this task, people usually use text. So they assume that it's transcribed and in a good way also.
Yeah, I guess in the research setting, we're starting from text because we assume that's what we have. And then maybe in a product setting, it's often audio, right? Something like Siri or Google Assistant. I think this is more common than interacting with the chatbot for search. But yeah, then when we look at the research side, we can assume that the text the utterance has already been transcribed, I guess. Mm-hmm.
Okay, so when we talk about conversation, so we're gonna be assuming that we're talking about text from now on.
Yeah.
So that
seems a bit unnatural, but it simplifies somehow.
So before we jump into the details of the topic, why did you choose to start working on conversational search instead of conventional or query-based search, or I don't know how you call the other?
Yeah, so I think it's a very interesting area because as we have more big data sets and neural methods and so on and so forth, there is increased capabilities of the systems for natural language understanding. So I think through conversation interactions, you can also maybe express more complex information needs. And it makes sense that also through the interaction, the user might want to ask related questions that have some sort of coherency, which is what we see here. And I think this interaction basically is a very, very interesting topic that's here to stay.
So, I mean, I think you kind of already hinted at that, but my next question was like, what makes conversational search more challenging than regular search? So can you speak to that a bit?
Yeah, I think so. Indeed, it's the natural language understanding capabilities, first of all, at least in this setting where we assume that the conversation part is in the query. So if you think of how humans converse, it's something very, very complex, right? If you, especially in the beginning when people were trying to search, you would go to the search engine and type terms that you were you would try to make the query as easy as possible to the search engine. But this doesn't happen when you speak to each other, right? So that's the ideal state where we would like to go, but of course we're quite far away from that.
Yeah, that's kind of interesting, but I remember being told as a kid, like how to use Google. Oh, like don't use top words, just kind of just like type like just important words and skip the rest. And I feel that's a behavior that's been changing right in the past.
Yeah, I mean, that's almost, this doesn't work as well as it used to, I feel. I don't know of a good study on this, but just entering keywords into Google is not what it once was from my personal user experience.
Yeah, absolutely. We're going to be anchoring this discussion in this paper that's called Few-Shot Conversational Dense Retrieval by Shi Yu and colleagues from the Tsinghua University and Microsoft Research. And this paper was published in May 2021. So can you give us a sneak peek of what this paper does, why we chose it, and why it's sort of important in this space of conversational search?
Right. So this paper is looking, as we said, at the conversational passage retrieval task, where the main idea is that you have a user asking questions to a search engine, to an interactive search engine, and it expects to get relevant passages back. So we can see an example here in figure 1. The first question might be, tell me about the Bronze Age collapse. The user gets a relevant passage back, hopefully, and then he asks the follow-up question, what's the evidence for it? So this is basically the task that we're trying to solve. And it's different from ad hoc search in the sense that in turn 2, you have to also take advantage of the history to understand what's the information you need of the user. And the reason why we chose this is that it's the first paper, to the best of my knowledge, that so most of the papers, the way they try to tackle this problem is that they take the second question and they rewrite it in a way that's self-contained. So it turns into Bronze Age collapse, and then they do ad hoc ranking with common methods, right? But this is the first paper basically that ingested the conversation as a whole and built a dense representation out of it. And I think that's why it's a really interesting paper. Okay,
and if I understood correctly, we're talking there's a document or a list of documents retrieved per turn of conversation.
Yeah,
right?
Exactly.
It's not like there's a conversation at the end, so there's always an interaction between the.
Right. Yeah. Every time you say something, you express some information needed, you expect to get some documents back, I suppose. And so you may ask up another question informed by those documents. So, the first one asked about the Bronze Age collapse, and then the second, what is the evidence for it? So what is the evidence for the Bronze Age collapse would be a more complete way to say this, but this is one of the challenges. We need like a query rewriter, or as we'll see in this paper, some other way to include that information from the context.
Okay, can we start talking about I think I would start with the representation side of things. Do you think that makes sense? How documents are represented, how questions or conversations are represented. I mean, you already hinted a little bit on that. So why don't we start with passage representations. How do people normally represent documents or passages in a conversational search setting?
Yeah, right. So in the context of this paper, you have a dense retriever. So most of the paper, the method is based on ANCE, as I call it, which is a dense retriever for normal ad hoc queries, and it has, I think it's a bioencoder model.
Yeah, so this is a type of bioencoder.
Yeah.
You insert some text, you get the vector representation out.
Yeah, so basically the idea is that you have a query, you embed it into a dense space, then you have all of the document collection which you have already embedded in the dense space, and then you do maximum inner product search or approximate nearest neighbor search to find the closest document to the query.
So this is pretty much equivalent to what you would find in other dense retrieval settings that we've talked in the past.
Yeah, I'd say so.
Yeah, exactly. And the previous methods don't necessarily have to be dense retriever methods, since most of them just produce a text which you can use in any way that you want.
Mm-hmm. Okay. So that said, how do you represent conversations?
I think maybe the easiest way, if we consider the query rewriter, so resolving that it, for example, we just don't need to do anything different. We've written the query, so now our query is what is the evidence for the Bronze Age collapse, and now we can just use a bioencoder write normal, I think, right? Yeah. So I think that's the simplest case.
So rewriting the query into I think you used before decontext. What term did you use for the?
Into a self-contained query somehow that does not depend anymore. You don't have to read the history basically to make sense of it.
Yeah, so like a term like it, he or she would need to be resolved to another term.
Exactly.
This is the intuition here.
Yeah. No, that makes sense. So how do you rewrite a conversation into a self-contained query? Or how people have tried to do that?
Okay, yeah. So what had been really common up to this point was that people would just there would be a system that reads all of the conversations, so Q1, Q2, Q3, and then it would produce a new query. So, for instance, what is the evidence of the Bronze Age collapse? And then you would feed this into a first stage ranker, could be BM25 or a dense retriever, and then you would typically also do re-ranking with BERT or T5 and so on and so forth. So yeah, basically this had ended up being like a pipeline approach where you have a query rewriter or resolver, whatever you want to call it, and then a first stage ranker and then second stage ranking, which basically a typical ad hoc ranking case.
Yeah, or you could say that you basically turn a conversational search task into a conventional search task by doing this step, and then whatever methods apply, right? Is that?
Yeah, exactly. It's like a query rewrite step, and now you're in normal ad hoc retrieval land. And so Colbert to bioencoder, BM25, anything can be used, I think.
Yeah, right.
But this paper does something a bit different, right? So I guess they're getting rid of this query rewriting step. Is the idea?
Exactly. And so far the most interesting part or important was the query rewriter for this task, right? And the different types of methods that people usually use to do query rewrite is that they were either trying to pick up terms from the history that were relevant and append, concatenate them in the end of the query.
Okay.
So in question 2, you would ideally pick up Bronze Age collapse, and your query would become, what is the evidence of it, Bronze Age collapse?
Okay.
So this is basically adding terms from the history.
And I guess it makes a lot of sense in a sparse retrieval setting, or because this is not like a natural language query, so to speak, right?
Yeah. And you also have methods that are based on full rewriting, sequence-to-sequence model that would rewrite it in a more natural way.
And actually, I don't know if you have any information about that, but how in sort of past research, how important is this rewriter step in terms of end performance? Is it like a really make it or break it kind of step, or pretty much anything goes when it comes to rewriting a conversation into a query?
I think for some queries, very, very important. So, for instance, if you see Q2, what is the evidence for it? Even if you have the best ranker in the world, I think it couldn't save this.
There's nothing. Yeah. So I think prior to this paper, it was very important to use a query rewriter. Is that true?
Yeah. I think so. Yeah. Or rewrite it in some way. Right?
I mean, assuming you have clear areas with these anaphora, like pronouns and so on.
Yeah,
I guess
exactly.
You must do some sort of rewriting without this approach that we haven't described yet.
I mean, the simplest way would be also to take all of the conversation as a history, as a query, but that might lead you to very contradictory results.
Or a lot of not important words being. And actually, I don't know if I'm misunderstanding something here, but is there any method currently or before this that incorporated the previously retrieved documents into a later stage retrieval? So what I'm asking here is, like, imagine I'm interacting with the system, and at turn 1 I ask what is the evidence for what was the example we were
Tell me
using?
about the Brandjades class.
Oh yeah, tell me about the Brandjades class. And then it gives me a few documents, and then I ask what is the evidence about it. I would expect the set of documents that are retrieved to be somewhat complementary to the previous ones, or something like that. Or is it something that's ever taken into account in these type of tasks, or is it really each turn is completely independent of the previously retrieved documents?
Yeah, right. So this has to do with the task and how the dataset is built and so on and so forth. So this was introduced actually in the CAST 2020. So Q2 could also depend on the previous retrieved passage.
Mm-hmm.
So you can imagine an example where the system responds with a passage, and the user finds something interesting in the passage and asks something about it.
Mm-hmm.
Right? So, which is a more realistic and more complex scenario, actually.
Okay.
So I guess it's something like anything the user has said or seen becomes part of the context, right? It could be the question they asked, but maybe they ask a question about the passage that the conversational agent gave back. Is that the...
Yeah, exactly. It's not so blind. So, Q1 is going to be this, Q2 is going to be this, and so on and so forth. But it's still, those datasets are still not real, right? They're so they have limitations in the sense that you still assume that there is one passage retrieved and it's always the same, so that the datasets creators are able to construct a conversation that is somehow consistent for everyone to use.
Okay.
There are these sort of limitations in general.
Yeah, I know, of course. It seems very hard intuitively to construct a labeled data set of conversations, right? Because it's like you can only follow one of the possible paths, and that doesn't give you that much information in a sense.
So I think typically there's something like teacher forcing, right? Where even if your system found the wrong passage, for evaluation purposes, you still show it the correct canonical passage. Is that true?
Right, yeah.
Just to keep things on track. I mean, it would be impossible otherwise. It's an assumption, but...
Yeah, exactly. Anyway, so if we go back to the method that's proposed in this paper, can we quickly get into that? Like, how is this different from the query rewriting step?
Right. So at inference time, you don't have to use a query rewriter. So what happens is that the dense retriever directly reads all of the conversation, and it encodes it into a dense representation, which is like basically the blue dots, the blue embedding over figure 1.
Correct, yeah.
Basically then you take this representation and you do inner product search with the document embeddings.
So you basically feed the whole conversation untouched, quote unquote,
right, exactly.
to the model, and then the model figures out how to best encode that into a dense vector. Now, they use here, in the few shot is in the title, and they mentioned that they use a teacher-student setup to train this model. Now, can you explain what is a teacher-student setup? Why is it necessary in this case, and how do they make it work?
Right. So this is actually the most interesting part of the paper also. How do you go from this conversation to the dense representation that's correct somehow, right?
Yeah.
So what people do in general in this space is that that's very common also for the previous query writers, that you have a set of questions, conversational questions, like the ones that we saw. And then you have, there are some data sets that provide rewritten questions by a human. So what we said earlier, what is the evidence of the Bronze Age collapse? So typically people before would take a T5 model and try to teach it how to rewrite the conversation. But in this paper, what they do is that they basically use a teacher, which is a dense retriever ANCE. And what they're trying to do is that they're trying to do knowledge distillation. So they feed to the student network the entire conversation, and then they try to make the embedding of this conversation similar to what the resolved query would be.
Mm-hmm. And then this resolved query is a manually created one.
Yeah,
so
exactly.
You only have as many labeled pairs as the data set provides, so to speak. Is that correct?
Yeah, exactly. So in each turn you would have the conversation up to this turn, and then the resolved query, and you would try to make those embeddings identical.
Mm-hmm.
So it's something like pushing the resolution into the dense retrieval model, so that the representation you get out from the full history is the same representation you would get out if you had rewritten it perfectly yourself. Is this right?
Exactly. Yeah.
Mm-hmm. And what scale are we talking about in terms of how many labeled pairs we're working with?
So the datasets are really small in general. So cast is about, I think, 200 queries, each of the datasets. So this is 200 turns, basically. Mm-hmm. Out of
we have this in table 1, actually.
Yeah, so I guess 479 for cast 19 and about 200 for cast 20.
Yeah.
So in total, they're just under 700, I guess. So it's not a lot of training.
That's very
data.
tiny.
A few shot is a fair way to describe that, I think.
Right, yeah. But actually, there is another data set which is called CANARD that people usually use that has many more questions that are also rewritten. So this comes out of conversational question answering. And I think it has something like 40,000 questions.
Okay, but this is like a conversation turns data set, not retrieval.
Yeah,
right?
Yeah, exactly. So the thing with this data set is that they only have the questions. This is not an open domain, so you don't have relevance judgments for the documents. You only have this is the question, this is the conversation, and this is what the self-contained question would be in that turn.
Okay.
But you can still use that as a workaround to get a good query representation.
I see. So in this paper, are they using this data?
Yeah, so they are using this data, I think, in the cast 20.
I see. So it's something like a lot of data for the task, and then within the specific cast domain, it's few shot. Is that a fair comparison?
Yeah.
Okay.
I can't really say anything about the data efficiency actually, because it seems that it's working pretty well in Cas19 already.
Yeah.
Which was somewhat of an easier data set so far. But I think they're using the rewrites for Cas20, so...
I see.
But their point with regards to the few shot is, I think that they are using knowledge also from the dense retriever, from ANCE. So the document representations are encoded already. So you already have some knowledge from the ad hoc ranking task where people have trained on MS Marco. So it's more easy to learn the conversational part based on that.
Mm-hmm. Yeah, I mean, my understanding was also that in the teacher-student setup, you don't like the amount of information that a single sample from the teacher provides to the student is way more like richer, because it's not like only a binary label or something, but it's like a full embedding of 700 or something dimensions that the student is trying to imitate, right?
Yeah, no, I think that's probably a good point, right? So instead of, this should be close to a 1 or close to a 0, you have, I think, 768 dimensions, and their loss is ensuring that every one of those dimensions is close to the teacher. So I think it's a mean squared error loss, if I remember right. Yeah. So the mean squared error between the teacher and student representations. So this is a lot more, I guess, meaningful.
Informative.
Yeah, I would say it's sort of an intermediate step also, right? So instead of trying to model the problem as directly, this is a conversation and this is the relevant document to it, you introduce a simpler task, which is, this is a conversation and this is how the query it should look like, and this is what the relevant document is. So for this is basically combined into two different losses. So one is the knowledge distillation loss, which is trying to make the conversation embedding, the blue one, as close as possible to the human result embedding, the orange one. And then you also have a ranking loss, which is trying also at the same time to bring the conversation embedding close to the documents that are relevant for that.
Right. And when they use the ranking loss, they're also changing document representations, if I follow correctly?
I think so. I'm not sure about the details of that, but
maybe it's unclear.
Yeah.
But at one point, I guess they have these two losses, and they use different combinations of them. Yeah. So they don't end up using both of them when we look at the results later. This knowledge distillation loss seems to be the main ingredient.
No, that's very interesting. Yeah, because it is true that in the section 3 from methodology, it does seem like knowledge distillation and the loss from the knowledge distillation and the loss from the rank are equally relevant, or they use both. But in practice, we see later that it can even hurt, right, to use a ranking loss as well in training the system. That said, you already hinted at some of these things, but can we recap on the data sets? So we have these TREC CAS 2019 and 2020, and these OR-QuAC. I don't know how you pronounce that.
We're not sure either, I think.
Yeah, this is short for Open Retrieval QuAC.
Okay.
So it was a conversational question answering dataset that people enriched with more documents to make it more like Open Retrieval setting.
Oh, okay. So what is the TREC cast dataset?
So TREC cast is the conversational assistant track that runs by TREC, which is a
evaluation forum, I guess. They run different tracks every year.
A typical sample from it would be the one that we discussed earlier from figure 1, where you have a user asking questions to a system, retrieving relevant passages, and then continuing asking more related questions.
And so the annotations in TRECcast are the conversation at turn K, then rewritten query by human that represents that. And then out of the documents, these 38 million documents, relevance judgment for the top document. Is that how it works?
Yeah, exactly.
Yeah, I think more than the top, right? Or for some subset of documents.
Yeah, they're not evaluated exhaustively, obviously.
Right. Yeah.
But there's a bunch of...
Yeah, there's more than one relevant. And then I guess there's also a single canonical answer in later years of cast.
Yeah, right. To be able to continue the conversation, basically.
Okay. And I think we've mentioned this once before, but TREC, how it works is that every year they create like a new version of their data set, and that's like researchers are blind to that and they can submit methods to it? Or is it that you get that data and you can run your experiments on it? Or...
So it's the former. Actually, they choose what to evaluate, so which documents to judge for relevance based on the researcher's participation. So everyone gets the queries in some documents, but then everyone submits their systems and they can do some analysis of the documents everyone found. So, you see that 3 people return this one document for Bronze Age collapse, so this is an important document to judge. It was returned by those 3 at a top rank, right? Whereas a document at a bottom rank returned by one system probably won't get judged. Their judgment budget, probably doesn't reach there. So it's like a cooperation in the sense of building good systems such that we can find good documents to judge.
Okay.
Kind of.
And then they publish the data based on that you can reuse.
Exactly. Yeah.
Okay. I think that's clear. And yeah, like we said before, the scale of these documents, these data sets, you can see in table 1, it's pretty small, right? We have 50 conversations in CAS 19, 25 conversations in CAS 20. The number of questions is in the order of 500, 200, something like that. So it's, the few shot setting, like Andrew said, really applies here. And then we have this OR open, what do you say again?
Open retrieval.
Open retrieval QuAC. You said is a data set that was augmented by people. Can you recap that?
So basically QuAC is a conversational question answering data set. So in this setting, people do not care that much about finding the correct document, but they care about retrieving an answer span. So retrieving an exact answer. And the way it used to be was that one conversation was regarding a Wikipedia entity, a Wikipedia page. So there were different questions being asked on that. And the systems had to return one or more spans that were return the correct answer. So the focus was more on what people in question answering call the reader. So finding the correct answer span rather than looking through the entire collection of documents and finding relevant documents. So those can also be combined if you, as you can imagine, because ideally you want a system that you don't necessarily want to answer questions based on one specific document. You want to ask open-ended questions and be able to fetch the correct document and then get the answer. So this is also kind of the difference between the question answering and the passage retrieval, conversational question answering, the conversational passage retrieval.
I see.
Part.
But what they do in this document in this data set is they repurpose these by like extracting passages where the answer is or something like that, or.
Yeah, so the relevant passage is the passage that is known to be relevant from the previous QuAC dataset, and then they enrich it with more passages so that they can make it open domain, basically.
You mean like with negative passages?
Yeah, exactly. Exactly. And it has a bit of a shortcoming or limitation, if I might say, because in this case, all of the questions in the conversation refer to one specific
like the Wikipedia
passage.
article or something.
Passage or document, actually.
Okay.
Document. Yeah. So it's a bit more easy for the system to cheat in that sense.
So I see what you mean. There's like a very strong
Yeah. So I mean, even if you did nothing to the query, I feel like you could still do well then, right? Because no matter which query you pick, it should be the same document. Is that a fair assessment, or maybe it's becoming complicated?
Yeah, maybe. I'm not sure actually. It kind of depends. I'm not sure on the details because maybe the document is split into passages anyway, so you still have to get the correct passage.
I see.
But those are very much related, and if they come out of a single Wikipedia article and then you have BERT or T5 pre-trained on Wikipedia, then it starts to get a little bit...
Yeah. Like a lot of information can be leaked throughout parts of the model in sneaky ways or something.
Yeah.
Okay. And as we can see in table one, the good part about the good side about this model, or one of the good sides, is that it's substantially bigger than the other ones. The train set contains 400 conversations, more or less. Right. Although in terms of like in other contexts, that's not that many labels.
No, like it's small, I guess, compared to MS Marco, but comparing these data sets, it's a good amount. Yeah,
yeah, it's 100 times bigger, I would say, right, compared to cost.
Yeah.
Okay, so I think that then we can jump into the discussing some of the results. Maybe you can briefly mention the metrics that they use. MRR, NDCG, whole at 10, which is something that I hadn't seen before. What are these metrics that they use? So let's start with mean reciprocal rank.
So this is 1 over the rank of the correct document. So you kind of assume there's only one result. So if it's at position 2, it's 1 over 2, 0.5 is your MRR.
Mm-hmm. Okay, yeah, we've talked about this. I think it's pretty clear. Yeah. In terms of favoring recall precision kind of thing, where does MRR sort of fall, or does that make any sense?
Well, you're not going to get much credit for anything that's very far down the ranked list. So even at, position 20, you're only adding 0.05. So I guess you're favoring precision in some sense, I would say. Mm-hmm. It's very focused on getting something in a top ranking, I suppose. So like the type of scores they report, 0.6, 0.5, 0.7, this is very close to the top of the list, if not at the top.
Mm-hmm. Okay.
Right, because if you get a relevant passage in the second spot, it would be 0.5, right?
Right.
Yeah.
Right. Okay. Yeah, plus we're also only looking at one document. So maybe that's a better explanation. It's not recall focused because no matter what, we only care about one document. Positions 1 in 10 versus 1 in 1,000 have the same score.
Yeah, I guess my question came a little bit from, you said before that this passage retrieval task is a little bit analog to the... In a question answering system, you have the retriever and the reader, and this would be sort of equivalent to the retriever, right? And I think we've talked before, in the retriever part of a system, it's more important to have the relevant document somewhere within the top 20, or like you don't really care that much if it's top 1 as long as it's there, because then a reader might be able to re-rank it to the top or something like that. So I thought it's interesting to look at what metrics they provide in terms of like, do they make sense in this setting or not? Because I'm a bit puzzled. I mean, I feel like metrics in information retrieval, there's so many to choose from.
We
so
pay a lot
places where you can cut off, and it's kind of, I mean, it seems a bit arbitrary sometimes to me.
I think the task here is not exactly the same as what you would always do with a reader-retriever. That may be part of it. So if you have like retriever-reader, you expect like a really concise answer to the question. Like, what year was Amsterdam founded? Some year, or like a very concise answer. But there are types of questions where you just wouldn't expect it to be so concise. So this example about the Bronze Age collapse, I'm not a historian, obviously, but I suspect you can't give a single year for that. I think it's probably old enough that there are different ways you can look at it, and you can say, it was over this period of time, and we know these for this reasons. So kind of the flavor of the information need is often different also. So here, the way I look at it, at least, is we're looking at questions that are really hard to answer succinctly. Like you would expect a few sentences in order to have a really good understanding of the answer. You could give us just 1 year for the Bronze Age collapse, but it misses all this historical nuance about, it's not so simple as this year it happened. Is this a fair?
I think it also has to do with the fact that the return thing from the reader or the retriever is different, right? So in the reader you typically get a span. So people usually use exact match or F1 or something like that to evaluate it, whereas this is more like a retrieval setting where you care about NDCG or you could argue that you care about the first place only, especially if you have an assistant that is not going to tell you, okay, this is the 10 passages that I found.
Right.
But I think for the interest of seeing how much progress we make, you might want to look at things like NDCG at 3 and
okay. So what is NDCG at 3?
So it's basically looking at the 3 top positions, and it assumes that the probability, I think, that the user will start looking at the lower positions is lower. So if you get a correct hit at the first one, you get 1 or 0.8, I think. And then as you go lower, you get... so if the first and the second passages are correct, you get 0.8 plus 0 point something else.
Yeah, I think DCG is discounted cumulative gain. So the idea is you lose a lot as you move down the ranked list. So it's way better to have that document at position 1 and 2 than 1 and 3. So that the score of relevant documents at 1 and 2 will be much higher than the score of placing them at 1 and 3, even though it's just a single position. Okay. So there's the user models, like there's really heavy discounting. You're really unhappy to keep going through.
So in some sense, you're trying to sort of include the psychology of a human that might be using this system to sort of reflect that? Or?
Yeah, I mean, behind most of these metrics is some type of user model or an idea of a user model. Yeah, so the user model here is the user just cannot read very far. I mean, this is even common for web search, right? You may look at the first 10, but basically no one is going to go to the second page even.
Right? So, if you want to hide something, you hide it in the second page of Google.
Exactly.
Okay, and then we have finally these holes at 10, which actually I'd never seen before mentioned. What is this?
This is also sometimes called judged at 10. I think that may be slightly more common in the past. Hole at 10 is appearing more, but it's kind of how much uncertainty is in the top 10 documents. So if all of the top 10 documents had been judged, your hole at 10 I think would be 0. Your judged at 10 would be 1. If half are judged, it's 0.5. So it gives you some notion of how reliable these metrics are.
That's super interesting because, I mean, the first episode we talked about this MS Marco, the sparsity of labels and how that might affect. And I feel it's, it's often not reported, and it gives, like you said, a lot of information about the uncertainty of that, because a lot of the non-judged documents might be irrelevant. And that's...
and this is basically the issue to some extent that TREC competitions try to solve. That because you cannot evaluate everything, you have people submitting their best systems. But obviously, as new methods come in, you might argue that they have brought documents that older methods, like term matching methods, wouldn't be able to find. So you're not sure if some of them are actually correct or not.
Mm-hmm. So you have more density of annotations. You trade off. You trade off the scale of the labeled pairs by how densely each query or each conversation is annotated in TREC. Is that correct?
If by density you mean, I guess, how well you can identify what documents to judge for the query, something like that.
Well, I meant more like how many documents are labeled for relevance per query.
Right. So I guess the goal is to try to label those at top positions from the participants, because as you see from the metrics, NDCG at 3, it's okay if position 20 is not labeled, but we want to have a lot of best guesses, I guess, from participants to try to label those. So,
okay, I think we can jump to the table too. So this is a really big table. There's a lot of numbers, as we were discussing offline. So maybe can you help us? Well, can you first describe what the rows and columns of this table are, and maybe highlight some few parts where we can see interesting things happening?
So there's like 3 datasets, as we said, and you have different evaluation metrics. Those are the columns, and then you have a set of public baselines, which are basically systems that people have submitted in the CAST competition. And what's interesting about them is that it's not very clear to say it's there mostly for reference, because it's not very fair to compare to each other, because each of them uses a different first retriever, re-ranker, query resolver. So it's not entirely clear what's best, if I may say here. Mm-hmm. Then you have the first stage retrieval only, where you only do the first stage retrieval. And you have BM25, ANCE, and ConvDR.
So maybe we should look into these for a second.
Yeah,
so,
I think so.
We have we have the raw query, the query with rewriting, and then ConvDR, which is the student-teacher approach.
Mm-hmm. Exactly, yeah. So what we see here is the row is basically just the last turn. And we see that the methods, the query writer methods and the ConvDR method clearly outperform this. And then it's interesting to compare, I think, ConvDR with ANCE query writer. Mm-hmm. So this is a system that is using a previous sequence-to-sequence rewriter. Mm-hmm. And yeah, what's interesting is that you basically compare this pipeline approach with a previous rewriter with ConvDR, which is basically constructing the embedding directly. And what we see is that it works better, ConvDR, compared to that.
Uh-huh.
Yeah, a pretty large improvement across metrics and all 3 data sets, I guess. So
yeah, absolutely. Right.
And this would have been the best prior to ConvDR, right? The normal thing to do would be something like a T5 query rewriter. So it's a clear improvement over.
Yeah. I'm not sure if it's the best query rewriter there is out there, but
I see.
It's the most fair because both are using ANCE in the end of the day.
I see.
So if you look at the Waterloo run, this is a much more complex system that is using hybrid dense and sparse retrieval plus T5 re-ranking, so it's not really fair to compare those 2 systems.
Right, and this Waterloo run is better than ConvDR, but there's a lot going on here, I guess is the point.
Right, exactly.
Yeah.
Another thing that we can see is that the dense retriever performs better compared to BM25. This is both with the query rewriting or the raw query.
Yeah, so I mean, I guess that one of the things that is interesting to reflect a bit on is how sort of quote unquote fair are all of these comparisons, as in BM25 raw, ANCE raw. Could you optimize these other models more so that they perform more competitively with ConvDR? Or I don't know if
maybe somehow, but it seems like there's no unfairness that's obvious, right?
Yeah, so is your point regarding like hyperparameter tuning or something like that?
Yeah, all of this, yeah.
Yeah, I think I don't know to what extent they did like very extensive hyperparameter tuning, but you can imagine that this is actually why I like comparing ANCE to ConvDR, because it's the same retriever.
Yeah.
So, and I think the main novelty of the paper is the knowledge distillation approach.
Yeah. So you basically saying that the most important part of this table is the first stage retrieval only bit?
I think so, and because if you want to look at the raw results, imagine having the query, what's the evidence of it? You're not going to get good results anyway, right? No matter what hyperparameter tuning you do, I think, if you don't have a query rewriter.
Yeah, and in terms of the adding a re-ranker on top of these or the manual reference, what is interesting
I think before we go there, it's interesting to compare also ConvDR with the ANCE manual for the manual for reference. So this is basically an oracle where they have a human to rewrite the query. So this indicates some sort of upper bound on the performance of ConvDR, and that's really interesting.
Yeah, sort of. It's like the student cannot overtake the teacher, or it would be weird.
Actually, this happens on Cast 19.
Oh, wait.
If you look at it.
And seeing Cast 19.
Yeah, so ConvDR performance is pretty much the same as ANCE manual.
That's interesting.
And then Cast 20, it's a bit, ConvDR is a bit worse than ANCE manual, right? But it's not so far.
But in principle, it should be some sort of upper bound, right? Because it's only...
exactly. And this also shows us a bit that Cast 19 was a bit easier, quite easier maybe than the later versions of the dataset.
Yeah. And then I guess if we look at OR-QuAC, this totally breaks a student can't outperform the teacher theory. But this is probably because of that issue we were talking about with the passages.
It could be,
Right. So here ConvDR is actually substantially better than the ANCE manual. But again, we know that all the queries refer to the same document, so maybe this can be used, like you were saying earlier.
So basically you have more chances of getting an easy query out of the entire conversation, which you can find, right?
Yeah,
that's a very interesting point. Yeah, I had missed that. It clearly outperforms the...
Yeah, but this is not such a fair setting, right? So I think the principle of you don't expect the student to outperform the teacher is pretty fair.
Yeah. But that sort of speaks to what Antonios mentioned before about the potential weaknesses of this data set.
Yeah. Right? On the other hand, though, I think you wouldn't expect it to outperform it because you wouldn't expect it to perform perfectly. But then I might argue that if you have a conversation that the terms are pretty relevant to each other, it might be the case that it's easier to find something relevant, right? So if you have a big semantic mismatch between the query and the document, and then in the previous turns you have some more relevant stuff to the topic, it might be easier to look at the entire conversation and get a good passage than only the last query, even if it's rewritten, right? So that's an interesting also characteristic, I think, of conversational search.
Yeah, I'm guessing it. I mean, if I understand correctly what you're saying, if ConvDR is initialized from a pre-trained language model, it already incorporates a lot of, or intuitively should incorporate a lot of kind of knowledge in how things should combine or something. So maybe that could sort of leak into and improve the performance of the ConvDR versus ANCE. Is that sort of in the same line of what you were saying, or not really?
Kind of. So my point is that imagine you have two settings. One is that you have the query, what is the evidence of the Bronze Age collapse? And then you have an entire conversation that is talking about Bronze Age collapse. And then you're trying to model your information need based on that. So my point is that I could imagine a scenario where having access to the conversation would help to alleviate this mismatch between the query and the document.
Yeah. So if you have like a conversation that's always getting more specific somehow, like you start with a very big topic and every time you ask a question, it's zeroing in a bit more on a specific part of that topic. So here, for example, is what you're thinking of, right? Where it could help because, if you go back to previous queries, it's just other related terms that you're making more specific.
Yeah, exactly. It's not clear that this could happen because if the topic goes somewhere else, then it's harder to rank with the conversation.
Right. Yeah.
But
yeah.
It's an interesting characteristic of conversational search, I would say.
Yeah. And didn't in CAS 20 they made these a bit more complicated, the trajectories? Or maybe I'm thinking of a later year. But for example, changing topic in the middle of the conversation, does this ever happen in the data?
I think that there are more topic switches, if you might call them, in CAS 20. And another thing is that you also had this canonical passage. So the user, typically most of the systems were including the passage in the query. So the conversation would also have the last retrieved passage. So this complicates things a bit more because you have a bigger length of the query and stuff like that. So it is definitely a more complex task as we go forward.
Okay, but in terms of general gist of it, we see that ConvDR clearly outperforms all other first stage retriever baselines by a large margin.
Yeah.
And that it's fair to say that set at the time it was probably, at least it set it apart clearly from the rest of them, right?
Yeah, and it even performs really well compared to the Oracle query rewrite. So not only it's better, but it's quite close to the, something like an upper bound.
Okay, so is there anything interesting that we can say about the next part of the table where they include the re-ranker step to the system?
Well, of course, the metrics go up because they're using a cross-encoder re-ranker on top of the dense retrieval. This generally helps. It helps more, using their teacher distillation approach than it does giving the re-ranker a rewritten query.
So actually, something that I don't quite understand, is this re-ranker trained only on the cast data, or is it an off-the-shelf re-ranker that they grab from somewhere else?
So I think they say they train it on MS Marco and the QuAC with manually reformulated queries. I'm not entirely sure what they mean by manually reformulated. And honestly, I'm not sure also how they're applying the distillation here, because the output of a cross-encoder is a single vector from which you would predict a relevance score. So I don't know that you would take that vector and use mean squared error distillation to try to make it look like the query representation. This is odd to me.
That doesn't make sense to apply knowledge distillation.
No,
in this,
but they talk later. There's a table where they look at knowledge distillation with the BERT ranker. So they are doing something here, I think, some kind of distillation, but I don't know exactly how they're formulating it.
But I think they definitely do MS Marco.
Yeah, they definitely train it on MS Marco, and it's a BERT re-ranker. Yeah.
Okay. And I think that we've covered most of the things in table 2. But like you said, I think it's interesting if we can quickly comment on the ablation on different losses, because we see some interesting, unexpected phenomena there. So if we go to table 4, we see these different results using different training paradigms. So can you maybe describe that and talk about it?
So what we see in CAST, here they have 4 settings. One is zero shot, which I believe is taking the last query only and ignoring the conversation. The knowledge distillation loss, which is trying to mimic the human embeddings. The ranking loss, which is trying to learn from relevance labels, and the multitask scenario, which is combined. So what we see is that in CAST 2019, knowledge distillation works best. And the ranking loss fails quite hard. It's even worse than is just ignoring the entire conversation. Now, this could be, I would hypothesize this is because of the very few training examples.
Makes sense.
Which is, in general, a problem in conversational search.
Yeah. And like we said earlier, the knowledge distillation loss is more informative than the relevance loss, I guess. So maybe it can better use the training.
Right. I mean, it seems reasonable that you wouldn't learn a good model only by a few dozen ranking
Yeah.
labels, right?
Yeah, I mean, they're initializing it from the ANCE checkpoint, but the difference between that checkpoint from MS Marco and this conversational data, I guess, is large enough that something good doesn't happen if you start from there and just train with a ranking loss for a limited time.
And then we see something a bit different for the QuAC data set, I'm guessing, because we were working with more labels here, so the ranking loss does perform better, right?
Right, yeah.
Yeah, so in the previous table, I believe for QuAC, they used both, the combination of the losses, and then, of course, only the knowledge distillation for CAST.
So I guess a good clarification. All the results that we were talking about before from the first stage retrieval only, all of those were trained on the knowledge distillation task only. So no ranking loss used.
Yeah, that's a good point.
All right. So very quickly, can we comment on the speed of this thing compared to other methods? Because one of the arguments that they kind of try to sell, so to speak, is that this is faster than rewriting a query, right? Encoding it directly.
Yeah, so the one of the motivations of the paper is that we do everything in one step, and we can see the results of that here. So if we look at table 3 at the ConvDR total, it's even lower than BM25 retrieval.
Yes, I see.
Yeah. And also lower than the query rewriter, I was going to say, but I think I'm stealing your thunder. Sorry.
No worries. Yeah, so it makes sense. If you have to use 2 modules, then you also have to wait for the rewriter to finish. So you take the query and then do ranking. And that's not happening in ConvDR.
I mean, that makes a lot of sense. I don't know if there's anything else that you want to comment on this table. There's the batched. Numbers that it's we're discussing before is a bit unclear. I guess how they calculate that, right?
Yeah. So. My guess, I'm not entirely sure, is that they batch many queries together and then they divide the total time with the number of queries, which is not entirely fair or meaningful, because you typically care about how long before your user would be able to see the result.
Users normally don't batch queries.
Yeah, right.
But I'm gonna...
Right. Maybe you can show 512 results to him, so he's confused.
Just accumulate everything you want to search in a month and then fire all of them
right
at the same time.
Yeah, so latency is basically what you care about.
Yeah.
Okay. This doesn't fully reflect it.
Good. Okay, yeah, I mean, I think that the last thing that you mentioned before you wanted to comment on about these results is this qualitative results on figure 4, or is there anything else that you want to comment on before?
Yeah, I think this is a good, a nice figure to see. So what we see in figure 4b is the visualization of 3 different of the queries with the triangles, the relevant documents and the irrelevant documents.
So you see a T-S&E representation, which is like a lower dimensional kind of representation of this embedding space. That's qualitatively interesting.
Yeah, exactly. And what's important here is that the retrieval happens with approximate nearest neighbor search. So in the end of the day, what we want to do is to bring the queries close to the documents in this space, right?
The relevant ones.
Yeah, the relevant ones, the orange one. And what we see is that 0S is the zero shot, which is just using the last query. It's much closer to the green dots, the relevant documents. Then the knowledge distillation is the ConvDR method, basically, which is very close to the manual query, which is the Oracle. That's very interesting. That basically shows that you can do this in the dense space, right? You can bring those two together. And we also have as comparison the query rewriter, which is a bit lower in this space.
No, it seems to indicate that at least qualitatively, this intuition that the teacher-student setup is very effective at very quickly, with very few samples, learning to imitate this embedding space, right?
Yeah, exactly.
Yeah.
Anything else that you want to comment on before we jump into like some last broader remarks or questions?
Not on my end. I think that's it for the results.
Okay, yeah, so I guess that something that maybe you can give a couple of pointers on is this was from May 2021. Is there any other work that has built on these, or has this sort of become a more standard technique in the space of conversational search, where more people do this by default?
Yeah, so I think in CAS 2021 this was included as a baseline, which shows also the significance of the paper. And there has been, I don't think there's any paper that directly builds on that, but there is another paper by the Waterloo University, I think, that tries to do something very similar. So basically take the main idea is, again, take the conversation and project it into a dense space. So they try to do the same thing, but instead of using this the query rewrites to bring the conversation close to the query rewrites, they generate pseudo-relevance documents from large collections to try to learn how to bring the conversation close to the pseudo-relevant documents. So it's basically skipping this intermediate step of trying to model the embedding of the resolution to generating weak supervision data to do the same thing, sort of. The paper is called Contextualized Quesy Embeddings for Conversational Search.
From Waterloo, you said? I guess Jimmy Lin's group?
Yeah, I think Jimmy is also in this paper. So that's an interesting follow-up.
Okay. Yeah, so I mean, in a broader sense, I guess this paper sort of goes in the direction of making the conversational search more end-to-end, as in it removes one explicit step of rewriting the query. So my question is, in a broad sense, do you guys see the space of conversational search going more end-to-end, or like do you still see space for I mean, I guess this fits a bit more into the space of conversational AI, because I've seen some works that kind of have like chatbots type of thing that have language model and then interact with modules. So in my mind, it's like this modular system. So I guess the question is, do you think end-to-end is going to eat all of the pie, or is there still going to be space for modular types of systems where, you know, you did these explicit things of rewriting? And
You want to answer?
Yeah, so I'll start. Sure. I guess one thing we see in the paper is that they're better than the query rewriter, right? So even if you try to train a query rewriter from similar data, it doesn't work as well. So from that perspective, it seems like in this scenario, there's no reason not to do the query rewriting end to end, right? Assuming I'm not, missing some other baseline, and assuming their query rewriter works reasonably and so on. So, I mean, that's a big advantage I see, right? You can do it end to end, and you can do it better than if you had this separate rewriter model. At least, using the model they have here. Maybe there's an improved one later. But I mean, there are also downsides to this, right? So you don't know exactly what's happening with the query. I guess the query representation has changed in some way, but I suppose there's no way to know if that part of the pipeline is failing versus the usage of the representation. And I guess calling it that part of the pipeline is a bit odd because it is end-to-end, right? But you can imagine the model making a mistake as far as what document it matches, or making a mistake as far as what query representation it creates. And I guess without components, it's a bit harder to know what's happening here.
Yeah. Yeah, I think that's. I agree with you, and it's hard to say. I mean, using both would probably be the best, but then you obviously end up having huge systems that are hard to manage, train, and so on and so forth. I think an interesting part is finding somehow alternative ways to train things, such as this one. And if you can incorporate it in an end-to-end method, then that's great. Because you avoid all of the complications of latencies with the query writers and so on and so forth. So, yeah, I could also see an end-to-end future here, but it's challenging to say whether and how to make this work so robustly. And but I think this paper is a very good first step towards that direction.
Okay. So another thing that was on my mind is I kind of intuitively very much understand and I agree on why conversational search is very relevant and very important in information retrieval. As in, the ideal scenario, if I want to learn something or get some information, would be to get some human expert and then ask to them, and they will probably ask some question back or give some evidence, and then I will ask upon that, and then you refine your information need. And a conversation seems intuitively to me a very natural way to ask for complex information. However, it seems to me that in out there's not that many conversational or commercial conversational search systems, or at least I don't encounter them a lot. Most of them is just like a query box, and then you're on your own. So, do you guys think this is something that is gonna change as conversational search improves, or is it still gonna remain a niche in search, in the kind of more broader sense?
So I think that one of the issues here is that I would say that even this data set, although it's a very good progress, it's still a bit static, right? So you don't have real interactions. It's based on offline evaluation. You don't really... You have a sequence of questions that need to be answered that are close to each other, and you try to solve the language understanding part on the conversation, but you don't have that much, for instance, mixed initiative, so the system asking a clarification question. And this could go in many different ways and can become as complex as you want, right? So I think we're quite far away from that. But I think this is a really important first step, because we're talking about retrieval and search, so you have to somehow ground your knowledge into documents, and that's an important first step.
Yeah, and I guess thinking about whether this becomes popular, how common conversational search becomes, the user behavior matters a lot. Like, I would never go to Google and type in what is the evidence for that, right? Maybe it makes total sense with my last query, but the user behavior's got to change before you even have an opportunity to do something like this.
Yeah.
So I don't remember the specific blog post, but I've read Google blog posts where they give the sense that they're trying to move in this direction slowly, like to allow a bit more complicated interactions. I assume they're able to collect a lot of data from this, and then this maybe allows them to make them a bit more complicated. So I think this issue of having data, and even if you're a company, you may still not have data here, because that's not how people have been trained to use search.
That's a I think super interesting point about how users expect search engines to work in a certain way, or right. So you probably need a very slow shift or some. Like you said, probably if today Google started being conversational search, and it actually took into account all of the people would not change their behaviors overnight.
No, it would probably make it worse, because it would be using context that I wasn't aware was serving as context. Yeah.
Yeah.
Right.
But in that sense, do you think, I mean, you kind of answered that question. So you think that, for instance, in web search, commercial web search, it's going to move in this direction of, like, the default mode is going to be you start a quote-unquote conversation session with a, you know?
Yeah, for web search, I don't know specifically, but if you think of like a, you know, Siri or some sort of conversational agent, something where the UI is slightly different, I think that direction is likely.
Yeah, something like that would make more sense to me. Also, there was a feature in Bing Search actually where they were. I mean, those are kind of type of interactive search scenarios, right? So even if you go to Google, then you can see follow-up questions that you can.
That's a very that's a good point. It is some sort of conversational, like guided conversational search almost, right?
Yeah, it's more interactive search, I would say, right? Or there was another feature in Bing Search, which was that you were getting like sort of clarifications on the results. So you would type shoes and then you would get men's shoes or women's shoes, and you could click on it and go to a different query. But I think also that the most obvious use case for that is speech devices.
Yeah.
Otherwise, it's also the fact that people, as you said, assume they know how to use, and it's a bit unnatural to start chatting with the search engine.
I mean, the UI would have to change so that you're aware of what context you're bringing in, I guess. This is what's nice about conversation. You don't expect to come back in 30 minutes and say, what is it? And have that be meaningful, right? It's clear what the context is.
Yeah. I guess if I can include a little rant, you mentioned the assistance stuff. I don't know how this is developed, but I've been always surprised at how little context Siri, for instance, used. I happen to use an iPhone, and I don't know if they already changed it because I stopped trying to ask contextual questions about the previous interaction. But it seems to me that they are still not doing that, which makes me think that there must be a pretty hard technological challenge there or something like that. But then I see some of these works, and it doesn't seem like it should be that hard. But I mean, I guess what I'm trying to say is my experience with conversational assistants has been pretty frustrating, and my impression is that most people have a similar opinion on or similar sense on that. Do you have any insight on why these things are so hard to make work in the real world, or you know, in more?
To me, maybe part of it is that some of the context can be personalization. Like I say the same thing every morning to my conversational agent, and 40% of the time it plays Ed Sheeran, which is not what I was asking for. And it's literally one of the 3 things I ever say to it, but it always gets it wrong because there's no personalization, I think. And this is a separate, I think, hard problem because it's conversation. Okay. So there's that type of context. But then I guess there's issues of just effectively using whatever context is available, like in this paper. And I guess that's still unsolved.
Yeah, and I think it's if you try to think at the number of problems that maybe the assistants are trying to solve, it's a bit all over the place. So you might ask for an alarm, then you might ask a conversational question from the web. So I'm not sure how those would look like in practice, but I think there's many challenges there to be solved.
Yeah. No, it definitely seems like a space that needs a lot of exploration still. So
and the privacy, right? I don't know how much of real data can be used. I don't know exactly what they're doing, but there are obviously privacy issues here that come up more than in some domains.
Absolutely. I don't know. Do you guys is there anything else that you wanna discuss before we close off? More specific to the paper, more in general on where do you see this subfield of information retrieval going? For instance, is there any evaluation or dataset initiative that you're kind of hopeful about, or kind of that you think is gonna bring interesting advancements to the table? Or?
I mean, I think the Castella track has been doing really good work, and it's continuing. So I like to see how results change for this from year to year. Maybe do you know of any new initiatives? Or?
The other interesting part with CAST datasets is that they're trying to include more characteristics of the conversations to make them more natural. So including feedback or some sort of personalization. And this kind of stuff, but still the context of offline evaluation is still a little bit limiting, and this is why some people are also trying to leverage simulations, because you can imagine also that even if you had access to a user base, you have to first build a somewhat good system to be able to roll it out and then do A/B tests or whatever you want. Otherwise, your users will just go away, right?
Mm-hmm.
So it's that's, I think, a big challenge for conversational search.
Yeah.
So moving away from the static.
And I guess that it also, I'm guessing it has a danger of further dividing the industry and academic sort of efforts, right? Because I'm guessing, for instance, in this case, some of the big search players like Bing, Google, and they can do a lot of A/B testing, and they can maybe have a user base where they could potentially have some prototype of conversational search and a lot of click data and online evaluation. Whereas in academia, this is probably harder to set up. Do you think there's like some way in which these things could converge? Between in web search, for instance, or in other commercial?
Yeah, so I think the simulations are a good starting point, because academia can also use them, and the fact that even Google is not going to just deploy out in the wild a system that it doesn't know what it does kind of brings us closer together. But of course, I wouldn't say that academia and industry have the same sort of resources. Mm-hmm. Also, if you look at data annotations, and another challenging fact here is that typically if you look at MS Marco and how it was anonymized, I think it's very hard to release an anonymized conversational data set. So that makes it a bit more challenging.
Yeah, I mean, I guess it's only capable of making it anonymous if the query appears many times, and as you go deeper into the conversation, there's less chance of that happening, essentially, right? So I guess you're stuck with the most basic questions, possibly.
Yeah. So is your point that if there were already a lot of privacy issues with MS Marco, with conversational search, the chances that that a user is going to be identifiable by a conversation are much higher than for single queries?
For conversational queries, it's much more...
the trajectories are at least much more unique. I guess we can say that, right? Like a conversational trajectory can be very unique in the way that lots of people can ask how much money Bill Gates has, right? It's...
Yeah. No, that's definitely interesting.
And I think that it's more likely that you would also have like personalization prompts from the user in a conversation. It would come out more naturally also.
Which it's something that can't be anonymized, I suppose. Or
I think so.
It's not easy to deal with.
Yeah. Lots of problems to solve.
Too many.
All right. Is there anything else you guys want to mention before we close it off?
I don't think so.
Yeah, I think...
All right. Then thank you for listening, and I'll see you in the next one.
Thanks for the invite.
Yeah, thanks.